Alright, today we're going to continue our work with inequalities. We're going to look at different phrases and then rewrite those phrases as inequality statements. So we have kind of the ones that are pretty obvious. We have is less than, is greater than, less than or equal to, greater than or equal to. Now for each of these there's more than one way to say the phrase. So is less than can be said is fewer than, pretty straightforward. Is greater than is more than, again pretty straightforward. But now these other two get a little trickier. So is less than or equal to, we could say is at most or no more than. So that seems kind of counterintuitive since we're saying it's less than or equal to, and then we use the word most and no more than. So that's something we have to keep in mind. Similarly, for is greater than or equal to, we say is at least and no less than. Again, even though it's greater than or equal to, we say at least or no less than. So my tip is to think about using money or age as a way to help determine the correct inequality. So if I think about writing all the numbers that are at most 6, so if I think about this, if I had at most $6, that's the most I could have. That's actually less than or equal to. That's the most I can have. So I could have $6, I could have 5 or $4.50. Okay, so I can have at most 6. So this means it's less than or equal to. I could also look at the other way, write all the numbers that are no less than. You could think of this as not less than 3. So if I thought of this as age, anyone who goes to school is no less than 3 years old. That means someone could be 3, someone could be 4, someone could be 5.5 years old. No less than means greater than or equal to. So let's go ahead and look at some examples. Number 6 is less than, or number C is less than -4. So less than is pretty straightforward. Less than, and C is less than -4. Alright, next up we have a number K plus 5 is greater than or equal to 8. Greater than or equal to 8. So again, that one's pretty straightforward, greater than or equal to. On the left we have K plus 5. On the right it's greater than or equal to 8. Now one that's a little trickier, 4 times the number Q is at most. So the most it could be is 16. So if you're thinking money, at most you have $16. That means that's less than or equal to, because it's at most $16. Alright, so now I have to write the expressions. 4 times the number Q, we write that as 4Q, is at most less than or equal to 16. Alright, go ahead and give the on your owns a try. So n is greater than 1. W minus 3 is less than or equal to 10. The number z divided by 2 is at least -6. Oops, I forgot to write the 6 there. Alright, so just be careful. At least meaning it's got to be more than that particular number or expression. Alright, let's look into testing solutions. So a value that makes the inequality true is a solution, just like equations. And just like equations, we substitute in what we are testing in terms of the solution and see if we get a true statement. So it's as if someone has already solved this inequality and we think that x is equal to 8. Now we're testing it to see if that's true. So we substitute in 8 for x, and then we work down to do the math. Alright, and is 9 greater than 7? Yes, it is. Don't forget to answer yes or no, or true or false. Alright, so for B, we want to see if y is equal to 4. If y is 4 if this is a true statement. So we substitute in 4 for y, and we're testing, is that less than 27? So going down, we have 28 less than 27. I think you would agree 28 is not less than 27. Put a line through it, and we say no. And then for C, we have z over 5 greater than or equal to 5, and we're testing if z is 15. So is 15 divided by 5 greater than or equal to 5? 15 divided by 5 is 3. So is 3 greater than or equal to 5? No, it's actually less than, so this is a no. So again, we're just substituting in the value for the variable, and then we're seeing if we get a true statement. So go ahead and try the on your owns. Alright, so for A we would get no. B, notice 10 is greater than or equal to 10. So 10 is equal to 10, so that's a yes. And then C, 5 over 6, 5 6 is less than 1. Right, it's a fraction less than 1, so that's a yes. Alright, on to word problems real quick. So again, we're just looking for those phrases and writing the inequality. Since we have a word problem, we're going to want to define variables. So the NASA Solar Probe Plus can withstand temperatures up to and including 2,600 degrees. So up to and including means, well, up to would be less than, and if we're including the 2,600, that would be equal to. Now our goal is to write and graph an inequality that represents the temperatures the probe can withstand. So first we're going to define a variable. The variable is always what we're looking for, and we're looking for the temperatures the probe can withstand. So I'll do let T equal to the temperatures the probe can withstand. And I'm going to put in here in parentheses that we're doing it in degrees Fahrenheit, so that way we know the units. So that temperature can be up to and including, so it can be less than or equal to 2,600. Alright, so that would be our inequality, and to graph it, we're going to go ahead and use our standard method of that number, double it, and then do the opposites. So we do see that it does have the equal bar here. That means it can be 2,600, so we're going to do a closed circle at 2,600 degrees Fahrenheit, and then we want everything less than, so everything to the left, and then remember to shade in that arrow as well. Alright, now truly I don't know if this is that true of a statement, because I don't know if it can truly withstand temperatures that cold in the way negatives, but at this point we're just graphing the inequality given. Alright, so go ahead and try the two on your owns. Alright, so the first one, the cruise ship can carry at most, so that's less than or equal to, it can hold 3,500 passengers. So that would be P is less than or equal to 3,500. And then the last on your own, the board game is designed for ages 12 and up, so it can be 12. So it can be 12 and greater, so greater than or equal to 12. So I let A be the recommended ages, A is greater than or equal to 12, and then I drew my inequality. Alright, that'll do it for today.